When you look at an object in a plane mirror, that is a flat mirror, the image that you see appears to be behind the mirror. I mean, even though we know that we're in front, the image appears to be behind the mirror. And the image appears to be the same distance behind the mirror as the object is in front of the mirror. So how do we explain this and show this in a ray diagram using the geometry of the rays to help explain why the image appears to be behind the mirror? Well, we need to consider an object. Let's take X as our object, a little dot here. And we're going to take two rays from that object. There are hundreds and thousands of millions of rays coming from this dot, but we're just going to take two rays which are at different angles. And they are going to reflect on the mirror surface there and there. So we're going to use our normal lines, our protractor to measure the angle of incidence, that's the incident ray, that one that comes in, and the angle of reflection to find the reflected rays as they come out. Okay, so let's look at the normal lines to start with. These are the lines which are at 90 degrees to the surface at the point where the rays are about to reflect. We can then measure our angle of incidences there and there. They are different in this case, so I might call that one I2. And we can use our protractor to mark off the angle of reflection, which will equal the angle of incidence, as is the law of reflection. And what we'll be able to then draw are our reflected rays. Now, if we had an eye over here, and let's see, let's have a blue, I think. So, strange eye. There we are, an eye, a giant's eye. These rays will enter the eye, and probably need to draw it a bit bigger than that, and the eye will focus the rays onto the retina at the back of the eye, and the brain will think that these rays have actually come from a source somewhere behind the mirror. They look like they've come from a single source. So if we just trace those lines back now, here are the dotted lines. The brain thinks that they've come from an object behind the mirror, which we'll call X dash, and that's our image. The image is not really there. We call it virtual. Virtual. Okay, so there is how we describe and how we show that the image appears to be the same distance behind the mirror as it does in front. So this distance here will equal this distance here.